So students, so in this earlier video we did I did a mistake, which is here we are taking these two parts. Chords means HP is a chord and this O and something, this point is suppose T, this is a chord. So here we take the ratio of the both two chords, HE in EP into HE and OE into ET. This is not EC, this is ET. Okay. So ET is equal to how much? This ET portion is nothing but OT minus OE. So OT is how much? OT is twice R minus OE. Okay. So twice R minus OE. So this is not EC, this is ET. C is the center of the circle. Okay. This is a little bit small correction. So now we will discuss about how we can determine the wavelength of light source using Newton's ring. Okay. Determination of wavelength of source by Newton's ring experiment. Okay. So generally we have one practical in 4th semester major that we are using sodium light as source, and we don't know the wavelength of sodium light, so we have to find the wavelength of sodium light. So we can find out sodium light wavelength by taking the earlier calculation of the radius of the bright and dark rings. So one important concept is there in the formation of bright and dark rings consecutively. If we go outside from the center of the circle, then we get bright, dark, or dark, bright. So we get like that consecutive circles with increasing radius. Okay. Also the thickness of the bright and dark rings increases if we go beyond, or if we go away from the center. Okay. But the center of the ring is always find to be dark, because when at the center, if you see in this plano-convex and glass plate combination, at this point, at this center where the plano-convex lens and glass plate is at the junction, the touch point, at this point we have seen that the additional part difference lambda by 2, which is introduced due to the Stokes law, is 0, because the reflected ray, the interfered reflected ray are both from the same interface, which is glass interface, because there is at this point there is no air, at the contact point there is no air, because due to that reason this lambda by 2 becomes 0 and the central ring is become dark. So the next one is bright, then after that one is dark, again bright, dark. So like that we get the rings. So from that concept we can find out the wavelength of the unknown source. So for dark rings we get the in earlier class we get this expression for radius. Suppose nth dark ring, for nth dark ring we get the radius Rn square is equal to how much? N lambda and R. Okay, this is the expression for nth dark ring. So if we convert this into this if we consider dn is suppose the diameter of this ring, then dn is how much? dm is twice of rn, okay, or rn is radius is how much? dn by 2, okay. So this, if we put rn is equal to here dn square divided by 2 equal to dn square divided by 2 means this is 4 equal to how much? n lambda by r. So now dn square is how much? If we cross multiply 4 n lambda r, okay. So this is the diameter of the nth ring. So diameter of nth dark, suppose this is dark ring because this is the expression for dark, okay. So the n plus mth ring, if we consider the n plus mth ring dark, suppose, okay, n plus mth dark ring, then diameter become dn plus m square is equal to 4. Here n is there, so here in place of n we write n plus m and lambda r, okay. From these two expression, we can find out the value of lambda. So suppose this is equation 1 and this is 2. So if we subtract one from another, suppose subtract 1 from 2, okay, 2 minus 1 we get dn plus mth ring minus dn square equal to 4 n plus m lambda r minus 4 n lambda r, then we will get how much? We will get 4. So n lambda r will get cancelled out, so 4 m lambda r. 4 m lambda r is how much? This much. So from this we can find out lambda is equal to dn plus m whole square minus dn square divided by 4 mr, okay, 4 mr. So this is, so hence we can find out from, suppose this is equation, from equation 3 we can find out the value of lambda. So using the traveling microscope, we can travel horizontally and vertically. Vertical is to adjust the visibility of the ring, and horizontal is to find out the distance of the radius from the center. From center we can go to first ring, second ring, third ring. So we can find out from this microscope the diameter of the nth ring and n plus m ring. So that two value we get from this microscope data, and we put here, and similarly r is the radius, okay, r is the radius, which is okay. So now suppose we consider fifth ring where n is suppose fifth ring and n plus m is suppose 15th ring. N plus m is the abstract value, okay. So n and n plus m should have some specific value, means numerical value, so that we can find out the numerical value of lambda. So suppose n is the fifth ring and n plus m is the 15th ring, then from this expression lambda can be written as d15, okay. N plus m is d15 number ring minus d5 ring divided by 4. M is how much? M is, we know n plus m, okay. N is 5 plus m is 10, give us the 15. So m value is 10. 4 into 10 into capital R, where capital R is the radius, Okay. Radius of the curvature of the lower surface, that means this radius of the plano-convex lens. Okay, the plano-convex lens has some radius. Okay, so that radius is the capital R, which is given in the experiment initially. So from this expression, by getting the diameter of the 15th ring, diameter of the 5 ring, 4, and m value is 10, and obtaining our r value, we get the value of lambda, which is the wavelength of the source. In our experiment, we will consider is sodium light. Okay, thank you very much.